Good evening, ladies, gentlemen, robot people, and variations thereupon. I am a recent college graduate with a Bachelor's of Arts in Computer Science and Psychology. Yes, I know. What is she gonna do with that? I have no idea. And since I had to give this presentation to get my present degree already, I thought, why not double dip and post it for you all to bask in the glory of here as well? This is basically an accumulation of my 4 years of university learning in the Department of Computer Science at university, and I figured, why not share it with the wider audience that I have, given the fact that I got absolutely cheated out of my senior year. So, sit back, enjoy, and let me walk you through the journey of my senior project in computer science. Hit it, boys! On the screen, I am displaying snippets of various gameplays, some sped up, some slowed down, some have even been cut down from their original length to isolate the different aspects of what my program is capable of, and some of its present limitations, as well as other highlightable moments derived from said program that I have taken the liberty of doing for your viewing pleasure, just so you have something pretty to look at beside my lovely avatar. Yes. Anyway, using Java Effects, which is a library found within Java 8, I produced what you are seeing here on the screen before you, referred to as a GUI, or a graphical user interface, upon which are card nodes that are dealt, distributed, allocated, and played upon between both players. The card nodes consist of PNG image assets. Some of you might recognize from the game Gwent, the Witcher card game, and of course the background is just a simple green thing that I got from the internet. It's a JPEG. Deal with it. The program itself is capable of simulating a single game of Castle, which is a shedding card game, typically using about 2 to 5 players and a single deck of 52 cards. Although this program is only capable of facilitating a 2-player game. The 2 players consist of a computer system, programmed with artificial intelligence to assess the best possible card play for any given turn. And of course, there's the human player, the user. You. The instructions are as follows, with the object being to get rid of all of the cards in your possession before your opponent can by discarding cards of either equal or greater rank than the previous discard that you have. The enter button typically starts the game and initializes the castles and confirms all discards. As for game setup, initially each player will be dealt about 10 cards. 3 cards will be randomly selected for each player's unseen castle. 3 more cards will be selected by each player for their seen castle. And once each castle has been initialized, the player with the smallest value card in their hand will go first. This is usually a 3 rather than a 2, as 2s are regarded as special cards, but it can be any value so long as it is the smallest between the 2 players. Regarding the special cards, there are 2. Cards with a value of 2 will reset the previous discard and grant a second discard, whereas cards with a value of 10 will ultimately clear the discard pile, rendering those cards as no longer playable. If a player has absolutely no playable cards, the player must then pick up the deck and add it to their hand. At the same time, each player must have a minimum of 4 cards in hand at all times, while the deal pile remains unemptied. Only once players have depleted their hands completely are they allowed to then play the cards within their castle. Now, my program relies on user mouse input to select as many as 4 cards from the player's hand, as well as utilizing the enter key to pass between phases of the game, all of which are established by a switch statement within the play game class. The switch statement uses phase, which is a string variable initialized to deal to determine which case will be executed, wherein each case's respective method will be called enacting the action required of it, ultimately altering the phase variable. This method allows for simplicity in instances within each player's turn that account for such conditions where, say, a player is allowed to second discard amongst other conditions. So as far as deviations go, and other issues that I had, originally the planned functionality of my GUI involved utilizing mouse clicks and dragging to initialize different phases of the game, like dealing of the cards or the initialization of the castles. However, I opted to use the enter button to initialize the various phases with switch case statements instead, while limiting mouse input to the human player's turn and its ability to select cards. This was done for 2 reasons. First, I found that it was simpler to determine between turn phases during gameplay this way, And secondly, about halfway through my semester, I actually encountered an issue involving the Z-plane of my nodes that greatly impeded my progress for several weeks. Every time I would drag a card across the GUI, any overlap between it and other cards would cause the cards to disappear. Regarding stationary assets, while the cards would not disappear, all cards that had been initially discarded were completely obscured by cards that had been more recently dealt outright. This problem became exacerbated as I transitioned my focus from building the GUI to setting up gameplay. Because Castle relies on visual aspects, for the human player at least, to determine the next discard, discards that had been dealt first would be hidden beneath a discard that had been more recently dealt, and this was obviously a serious problem for me. However, while frustrating, the issue was eventually solved with a rather simple additional line to my code which allowed me to continue on with the project. However, this problem ate a great deal of my time in the end, and that was time that could have been spent debugging and testing the final product altogether. Next, the originally plain layout of my GUI involved a separate discard pile off to the side of the most recent discard pile. I did away with this idea and opted instead for a single discard pile altogether, as it made more sense to execute, and overall simplified the program via an ease of reference. Lastly, I included an instruction page for Castle in the initial phase of my game that instructs the players on how to actually conduct themselves while playing the game, along with its rules and limitations. This was not in the original proposal, but it was added as a kind of cheat sheet for the player. So moving on to user tests, it should be noted, obviously, that testability was limited due to the lack of willing participants in abundance. Furthermore, due to the randomness of card allocations for every game, each game is unique. Thus, each game launch presents with the potential for a never-before-encountered error. So while I've done my best to fix the obvious errors that have come up, roughly 25% of gameplays at this moment in the program's present form result in an incomplete run as of right now, meaning that the program comes to a point where it is incapable of continuing forward despite an apparent ability to do so. Currently, the average timed playthrough for an experienced Castle player is about 1 minute and 45 seconds, whereas the inexperienced Castle player will have a much longer playthrough. Furthermore, test users, upon questioning, had trouble remembering the rules and the limitations of the game while playing. Test users also expressed a desire for sound effects, which I think was a joke, but probably wasn't. Furthermore, beta testing yielded performance issues under specific conditions. This included the selectability of cards after the human player had accessed their castle and had the discard pile returned to them due to a lack of playable cards, amongst other things. Beta testing also discovered that the computer player has a particular preference for discard stacking the 2-value cards as opposed to the non-2-valued cards for some reason. Regarding foregone features and feature enhancements, there were a few certain features of the game of Castle itself that were foregone due to time constraints ultimately, one of these features being the use of jokers as a wild card. For simplicity's sake, this was omitted from the final product, but in future versions could presumably be implemented. However, its utility would heighten the complexity of the program for both players in the end, and I'm not entirely sure how I would handle that. Next, I neglected the computer player's ability to discard more than just a single card at a time, while the human player does in fact have this ability. The computer player was neglected due to time constraints, but ultimately this feature would absolutely be implemented, the result of which would be an increase in the difficulty of gameplay for the human player. Lastly, a feature not included in the final product is the ability to clear the discard pile after a run of 4 has been discarded. This is a future enhancement that would be much easier to implement once the computer player had been granted the ability to select more than one card for discard, but ultimately was neglected. Lastly, given user test input highlighting a concern that players were incapable of retaining rules and limitations after the initial instruction page during gameplay, this discrepancy in player recall has made it clear that the most important feature to include in any future enhancements must include a secondary scene with an instructional prompt the player can switch to as needed. Overall, I feel like I am a stronger programmer after having poured so much time and attention and effort into my project. Even though I know it's by no means perfect, and that there are absolutely plenty more things that I could do to improve upon it, I'm ultimately proud of what it is I've achieved this semester. If you had to ask me my confidence level in my programming skills prior to this semester, it would have been a pathetically low amount, I'm not gonna lie. The biggest obstacle I had actually wasn't my Z-plane issue, it was my imposter syndrome, to be frank. Getting over myself and asserting that yes, I can do the thing, it won't be easy, but it's nowhere near impossible, was... how do I put it? Intimidating. I went into this not sure of myself, not quite confident that I would actually be able to get it done. Worried that I might finish out the semester with just one major instead of the two as a result. And that this all might be for nothing, so obviously the pressure was on. But now, I'd say that I've vastly improved. I'd like to think. And maybe even learned a thing or two. Maybe. I've certainly grown in my abilities. My understanding of concepts like data structures and object-oriented programming have skyrocketed. More so than when I took those damn classes. Certainly more so. And of course, in my ability to test for errors, I have accelerated beyond what I thought was reasonable. I think that goes without saying, though. If I could do this project over again, it would be preferable for me to have the resources available to me by being present on campus. Of course, there's very little that could have helped what ultimately happened in the end. Obviously, I'm aware of that, you're aware of that, everyone and their mother's aware of that ad nauseum. But in addition, I would hope that it wouldn't take me as long to solve my Z-plane issue. Had that not been the massive impediment that it turned out to be, along with having to move so suddenly back to my house, I am sure, I am positive, that the final project would have had fewer bugs along with a few added enhancements. Absolutely. More than that, though. I think if I could do it all over again, I definitely would have made a website as opposed to this overcomplicated, array-riddled, tedious if-else statement monstrosity that I ended up creating. Just kidding. Look for Castle in the Android App Store sometime between now and whenever the hell I get around to it.